Hi everyone, welcome to this new lab. So this is our lab topology. Okay, and we have so basically this is BGP and uh, MPLS both combined. Okay, so here we have CE1, right, and here on the other side we have CE2. Okay, basically we can say that these are two customers, right? And the customers, these are the edge routers on the customer end. Okay, so both of them are in different AS, right? 65101 and 102, right? And then we have this provider network, which consists of P1 and P2, right? P1 and P2 are the edge routers of the provider network, and P1 is the core router, right? So basically uh, this is the provider P1 and P2 are in the provider's network, right? And they are providing some service for C1 and C2, right? So our end goal is C1 and C2 should be able to communicate with each other. Okay, so these all are uh, uh, you know the link related information, right? And the loopbacks we are using, right? This is my lab. Uh, Actually in EVNG, right? So this is how I have connected it. Okay, so let me log in into C1 and bring it here. So C1, um, I'll try pinging the other end, C2 from here, right? With the source as C1. Yeah, and we can see that the success rate is 0%. That means the ping is actually not working, right, end to end. So before starting this troubleshooting, right, let's first bring me this PPT here, okay, to go over what are technologies we are using, right, in this lab. Okay, so first we have OSPF, right? OSPF is used as an IGP in our core. Okay, in our provider network, we are using OSPF as the IGP, right? We can use ISIS as well, right? But here we are using OSPF, right? LDP is used for label switching, right? So in our core, we have MPLS. So based on that MPLS, right, we are using a simple LDP protocol for label exchange, right? We can use something like RSVP as well to create end-to-end tunnels, right? But here I'm using LDP to keep this very simple, right? Then we have VRFs, right? So VRF is basically on the edge routers of my provider, right? For uh, you can say a routing table separation, right? So we need that logical separation of routing table per customer, right? So we are using VRF there, right? Then we have MP, IBGP, VPN, V4, right? This is basically BGP extension, right? A BGP address family, which we'll be using in our network, right? So that we can tag the uh, routes with the correct VPN label and the route target, right? And then we have EBGP PEC, right? This is normal between our provider edge and the customer edge. We have EBGP session running, right? So uh, let's go over the first one, right? We'll be using OSPF, right? And in my lab topology, we will only have OSPF area 0, right? Because this is a simple 5 router topology. So we will only have OSPF area 0, right? So OSPF's responsibility here is just that to provide reachability, okay? To provide loopback reachability so that we can use it for LDP, right? So for label transmission, okay? And we have kept a single area, right? Uh, to keep it very easy, right? Uh, LDP we are using, right? LDP we are using for label distribution, right? And we will have one label per prefix, right, per hop. And this will be our normal penultimate hop popping PHP, right, which is the by default uh, way of in LDP, which is PHP, right? And LDP will work in such a manner that wherever LDP is configured, right, it will automatically detect and assign labels, right? So we don't have to define the labels manually here, right? It will be distributed between all the routers which are in that specific which are in that specific wherever LDP is configured, right? So we'll be using LDP for label distribution. Um, so just going in basics of label mechanisms, right? We have push, swap, and pop, right? On our ingress edge router on our P1, right, where the CE1 will be connected in the ingress, right? If we take the traffic from CE1 to CE2 on P1, uh, a label will be pushed on the basically on the stack, right? So before coming into P1, right, it will only be a you can say a route, correct, to the destination, right? And there we will push a label specific to that route, okay? And on the next in the P router, right? Uh, uh, or whatever are the you can say the backbone routers, right? There only swap operations will occur, right? Whatever are the transit routers, right? So push will happen on the edge router, right? On the ingress edge router. Swap will happen on the transit router, and then pop happens on the egress router, right? Generally on the one hop earlier to the egress router if you are using PHP, right? And if we use UHP, it will be on the last route, right? On the last egress route. Then we are using VRF, right? And VRF is used for separate uh, rib, right? Fib and say ceph table, right? So we will have a single device, but in a single device, we will have um, uh, if suppose your customers have a private address space, right, which will overlap with other customers, so we'll use VRF so that there is a complete isolation between the address space or the routes between all the different customers, okay? Then RD, and we'll use RD and RT, right? RD and RT is a route target, right? So RD is uniqueness, not policy. Okay, so suppose we have routes in our VRF, right? So each route will be tagged with will be prepended with RD, so that it becomes unique to that VRF, right? And then we'll use RT to target where to export and import that routes from that VRF, right? So next we will have MP IBGP VPN4, right? So we will have like this address family VPN v4, right? And we will activate specific neighbors in that address family. Okay, so address family VPN v4 is a dedicated address family. Okay. Um, It is also loopback to loopback, right? Like any general IBGP session. Okay, so we'll use loopbacks for VPN reachability. And then between our P and C, okay, the provider edge and customer edge, we'll use eBGP, okay, normal eBGP. We are not using static routes or IBGP here, right? Um, and this session, right, eBGP session lives under the VRF customer A, so that, and if there is some another customer connected to that provider edge, right, we can have it in another VRF. But here we have only one router connected to it, so I'm putting it in customer A, right? Redistribution is automatic. Okay. Uh, So this is the entire our entire technology stack which we are using, right? As I mentioned, just a brief overview. So SPF is used in the core for loopback reachability. LDP is used for transporting labels, right, and hop by hop reachability. VRF is used for rib and fib separation, right? So that we could have that customer separation, right, logical separation. Then we have MP IBGP VPN4, so that We can use some other things like RD, RT, and VPN labels, right, which will not be there in our normal BGP, right? So we'll use VPN for address family. Then we'll be using eBGP PEC for that connection, right, for with our customers. Okay. So with that in mind, uh, let's we have logged in into C1, right? And if I see the running config, if you see the configuration, it is our we will only have BGP. Okay, we won't have anything because this is our customer end, right? So from a customer end, we will only have uh, eBGP session with our C, right? So we already saw with our P. So we already saw that from C1 side, we are not able to ping C2, right? So let's see if we have the BGP formed here, right? Which should be, right? There is, so we have a neighborship with 172.16.11.2, right? So with our within AS65000, right? So we have a BGP neighborship with our basically provider. So there is nothing else, no other protocol running on C1. So just BGP is running. So this looks fine, right? Nothing from C1 side. Let's log in into uh, P1. Uh, Let me look at P1. Okay, now on P1, when I see on P1, okay, so if I see the running configuration on P1, we have this VRF, right? IP VRF customer A and RD, right? Which I said, which will be used for distinguisher, right? Route distinguisher, which will be added before any route, right? It is 65,010, and we are targeting, we are exporting and importing this community basically, right? And this community should match on both the ends, right? Then only these routes will be imported, right? So we have this community on P1 side, and we will expect that on P2 side also these communities will match, right? This route target will match, so that whatever we are sending from whatever routes are being sent from this side, those are matched and then imported on the other side also. Okay. So we will check that later. We have MPLS label protocol LDP. Okay. And our MPLS IP is enabled uh, on this core link, right? This core link is towards P1, right? The provider core. Okay. This is not on the CE side, CE1 side, because on CE1 side we do not need it, right? Because that is our plain BGP. There is no MPLS running on that, right? Otherwise, we have OSPF running, right? OSPF's work, as I said, is only to uh, loopback reachability, right? So we are using that. And if you see here, then this is router BGP, right? Our BGP running here, correct? And we whatever our neighborship is there, right, is on the three dot is under address family VPN v4, right? So we are using that as our neighbor, right? And with our VRF with our customer A, right? We are having uh, that neighborship under the customer IPv4 VRF customer A, right? So whatever routes will be received from this neighbor will go under this VRF, right? Which will be a separate routing entity on the same device. So that's it, right? So here we have OSPF running, we have MPLS running, and we have BGP running, right? So let's check whether I have the OSPF neighborship with my neighbor, right? I will have one OSPF neighborship with my neighbor P1, right? And I have that OSPF neighborship, right? It is up uh, and full BDR, right? So I have that. Now let's see if I have uh, show MPLS LDP neighborship. Do I have the neighborship with my P router, right? And I have definitely the neighborship with P router, right? So that should not be causing any issue, right? And this is under VPN v4, right? So let me check under VPN v4, right? So I have the uh, these routes received from the customers. Okay. So I have the BGP connectivity also. I have the MPLS connectivity also. I have the OSPF connectivity also, right? So I have all the three connectivity working properly on P1, right? Now let me check on P, right, which is our core router. On our core router, let's see on our core router. On our core router, we will only have uh, OSPF and MPLS running. Okay, so that's why it's BGP free. Okay, there will be no BGP running here on the P router, right? So this is only using LDP for passing the traffic, right? And we can check that, and we'll be using OSPF for reachability, right? We have MPLS level protocol LDP, right? And we have MPLS IP towards core towards P1, right? But ideally, we should have MPLS IP towards P2 also, but I am not seeing that, right? We'll check that. Let's go further and see. Yeah, we have OSPF running, right? And in OSPF, we have uh, interface towards easy fast Ethernet 00 and 10. Both are no passive. That means both are participating in OSPF, right? So we have basically OSPF towards both of them, right? But um, let's check the LDP status, right? On the right, I have only the the LDP with 1.1.1.1, right? Which is my P1, right? I don't have anything with P2, right? So that is a concern, right? We saw above that the command is not there, right? Um, under one of the interfaces, right? But one more thing which we should check is OSPF neighborship up with both of them, right? The OSPF neighborship is up with both of them, right? If OSPF neighborship is not up on both the with both of these routers, right, LDP will also not work, right? That's how LDP is designed, that for LDP to work, right, it should have the reachability to both of these routers. Okay, that reachability is provided by the underlying IGP. Okay, if it does not have that reachability, right, what you can say, the loopback reachability, right, on which LDP is getting formed, right. So first thing, whenever we are seeing that any LDP neighborship is not getting formed, right, the first thing we should check whether do we have the reachability with that loopback, right, if we are using LDP for our forming the loopback, right. So here in our case it is there, right. So the reachability is definitely there, but when I will see MPLS. Let's just show the entire running config again. We saw that MPLS IP was missing under one of the core towards the link of our uh, core link, right? On one of the so one of the core links is missing MPLS IP, right? So ideally, as I said, MPLS is there on all the from on the link, right? If from both of the provider edges towards the provider core, right? It should have the MPLS enabled, right? And from our this side also, from provider core to both of these P side, we should have the MPLS IP enabled. But if it is not enabled, right, we should go ahead and enable it, right? So conf T will take this interface. which does not have MPLS IP enabled, right? And we will enable MPLS IP. Let's see it. Right. So we saw that, right? LDP neighbor 3.3.3.3 came up, right? So MPLS configuration was missing on one of our interfaces, right? So that's why MPLS was not coming up, right? But as soon as we uh, made that change, right, we saw that MPLS LDP came up, right? So we have to remember that there are two pieces of configuration. One is we have to enable LDP globally also, right? And then we have to enable MPLS IP under each of these interfaces. Okay. If we miss any part of this configuration, it will not work. Okay. Specifically, this is my Cisco environment. Okay. It will not work for Cisco. For enabling LDP is different on different ecosystems, right? Maybe in Juniper it will be a little bit different. In Arista it will be a little bit different. In another platform it might be a bit different, right? But in Cisco we'll do it like this way. The main thing which we have to understand is for LDP the configuration should be present, right? Which was missing here. Another thing which is that for it to work we should have that reachability. Okay, LDP cannot provide the reachability. So the loopback reachability should be present for it to work properly. Okay, that is provided by OSPF here. So first you have to start from troubleshooting OSPF. If OSPF neighborship is not there, we have to start from there. Okay, if OSPF neighborship is there, then definitely we have to check with what is wrong with LDP. Okay, but in our case, OSPF was working fine, right? Here we are seeing now we have two peer LDPs which are there, right? We can see that it is on fast Ethernet 00. This is on 10, right? It shows the neighbor also, right? And yeah, so on this side right now, everything looks correct, right? So this issue we have resolved now. Let's try and see if we can ping the try to ping again, right? Has the issue been resolved, right? Uh, no, it's still not working, right? So there is definitely something wrong, missing again, right? So let's go to the next hop, right? We will go to P2, right, and see if something is missing on P2. Okay, have we made any configuration mistake or something on P2? So P2 configuration I am not showing, right, because I've already shown on P1. Basically, it will have MPLS towards its core, right? It will have OSPF for reachability, so it's a P2, so it will have BGP towards RC2, right? EBGP, right? It will have a similar VRF like customer A, right? Because same VRF which was on our P1 side should be there on P2 side also. Okay. Otherwise, that end-to-end reachability will not work. Okay. So uh, so we have this VRF. BGP is there, right? We'll check if LDP is working fine or not. LDP also it's there, right? LDP neighbor is there, right? Now let's check the VRF details, right? Is this VRF working properly? Um, it's fine. The default RD is 65,020, right? Interface, I am using address family IPv4, VPN route target communities is 65 for RT. Export it is 65,100. It is import 65,200. Okay. So it's not like import and export has to be same, right? It can be different. But on P1 side, our import and export both were same, right? 65,100 for VRF customer A, right? But here it is 65,200, right? So that as I was mentioning, right, on our both of the edge routers, the VRF should have the same, RTs. The RT should be matched for export and import, right? Export and import both can be different RTs, right? That's not that can happen, right? But it should match on both of these Ps, okay? Otherwise, that will break, right? Because the right, it will not be tagged with the right communities, and on this side will not be, this side on P2 will not be matching with the right communities, right? So let's check why that's the case. That is mostly a wrong configuration, right? I think so. Yeah. So here in IP BRF customer A, I have configured this with 200, which is wrong. Okay, so let's fix that. I will go under IP BRF customer A, and I will say let's import 100, right? But I have to also remember to know this earlier thing, right? Because otherwise it is not overridden. Uh, so I will do this. Okay, and ideally it should start working now. Let's see if that VRF thing is fixed now. Yeah, right. Here it is showing 65,100, and both of these are correct right now. Okay. Now let's see from after fixing this issue, are we able to ping right now or not? Okay. So yeah, I'm able to ping right now. Okay. So yeah, this was the lab. So we found out two issues, right? Both of them were in our case actually both were configuration issues, right? But this actually very well ties with what our infrastructure was built on, right? Whatever technologies we were building on, right? So um, yeah, after fixing both of those issues, right, we have resolved our end-to-end things are working, right? So just I'm closing this with this quick reference, right, which we talked earlier, right? We were using OSPF for our core loopback reachability, LDP for our MPLS, right? Label transports, VRF for our that customer separation, right? And MPI BGP for our route target, RD which we use, right? Our RT which was wrong, right? 200, right? So that thing, right? And then eBGP PC, right? Which is normal eBGP between our provider edge and customer edge. Okay. Thanks for watching.